Hello, this is Miss McCombs. I'm going to be doing a tutorial video to show you how to do the addition and subtraction algorithms, as well as how to apply it to single-step and multi-step word problems, as well as a tape diagram. Now we'll start off with a tape diagram. I know that it can be kind of tricky at first, but if you just think about a tape diagram as little pieces of tape stuck together to form one big piece of tape, that kind of correlates with our math and our word problems. When you have small parts added together to get a whole, then you have your whole tape diagram. So what I notice first is this definition says that it is a segment of tape, and it's used to illustrate a number relationship. So this kind of takes us from diagrams and bar models and fraction strips to a little bit more of an abstract understanding. So before, where you would have done these pictorial pictures in order to talk about how to do a problem, you might have done apples or you might have done circles. Now we're moving more towards our tape diagram. So these are our parts of a whole. Now these are the ones we're going to be working with in 4th grade. The first one that we're going to be working with is our part-whole model. If you notice, there's little pieces of tape stuck together to make one long whole piece of tape. We're also going to be using the additive comparison model. This is anytime you see word problems that might describe something like this much more or this much less. They're going to be comparison problems. So I'm going to be showing you an example of each of these. Okay, so here's our first problem. Anytime we have a word problem, no matter what, we use a strategy in 4th grade called CUBES. CUBES is an acronym that stands for C, circle the important numbers, U, underline the question, B, box in any math action words, E, evaluate what steps to take next, and S is to solve and check your answer for reasonableness. Another way of asking that is, does my answer make sense? So now when I look at this word problem, the office supply closet had 25,473 large paper clips, 13,648 medium paper clips, and 15,306 small paper clips. How many paper clips were in the closet? So I'm going to start off with C, circle the important numbers. Okay, those are the numbers that I see circled. All right, there's no other numbers I can circle. Now I'm going to underline my question. I'm going to back it up from my question mark. That's the easiest way. How many paper clips were in the closet? Now, here's what I'm going to do next. I'm going to box in any math action words. So math action words are words that tell you what to do in a mathematical way. So things like more or less or altogether, how many, those phrases are phrases we use in math that tell us what to do before we evaluate and solve. We're also going to look for units. So I know I'm measuring in large paper clips, medium paper clips, and small paper clips. I also see the phrase, how many. When I look at this one, it says paper clips in general. So that must tell me that I'm considering all of my different kinds of paper clips. So I'm going to put that in parentheses to remind myself. Okay? Now, there's one other math action word in here that you might not think to consider, but it is really important. It's this word and. The reason and is a math action word is because it's telling me all my 3 parts. For example, when you go on a trip, you may want to pack your clothes, your toothbrush, and toothpaste. So that means 3 different parts. Here we have 3 parts of paper clips in our closet. We have large, medium, and small. That tells me that all of my parts together equal all of them. So when I think about all my parts together, that might tell me that and is telling me to add. So I'm going to put a plus sign above that to remind myself. Now we're ready for our tape diagram. Again, just think about which tape diagram we're going to use. If it's giving me my parts, I need to find out how many paper clips were in the closet. How many total? So what that tells me is when I look at my tape diagrams here, I'm going to use my part whole. But instead of 2 parts, I actually have 3 parts. So the first thing I'm going to do is start with my big number right here. And I'm going to draw a bigger rectangle. This represents my little piece of tape. 25,473. Now, since I have that big one, I can move on to my next part, medium paper clips. Well, 13,648, is that smaller or bigger than 25,473? You're right, smaller. So when I do that, I want to make my box a little bit smaller to show that. And I'm going to put my number right inside. Now I have one more part to consider right here. 15,306. It's kind of in the middle. It's a little bit bigger than my 13,000 and a little bit smaller than my 25,000. So I'm going to kind of make it an in-between size. And put my number right inside. I want to keep organized so I can even label these parts. This is my large. This is my medium. And this is my small. Now, the only part missing from my tape diagram, if you look, we have our parts. We had 3 parts. We're missing our size whole. Well, that makes sense. Our question, back it up, said how many paper clips were in the closet. We don't know. That's what we have to figure out. So I'm going to make a bracket that represents the whole thing. And I'm going to put A. A stands for answer. That's what I want to figure out. So now I have my tape diagram. Now this is really easy to figure out how am I going to evaluate. We talked about adding parts and also looking at our tape diagram. It looks like I need to add these 3 numbers in order to find my total piece. Think about 3 little pieces of tape stuck together, figuring out how big is the whole thing. So I'm going to keep organized. I'm not going to stack all 3 at the same time because I might make a mistake. I'm going to do 2 at a time. So I'm going to take the first 2, 25,473 plus 13,648. Notice I lined up the place values. Ones with ones, tens with tens, hundreds, hundreds, thousands, thousands, 10,000s, 10,000s. And I'm also going to check off which ones I'm adding so I don't add those again. 8 plus 3 is 11. 7 plus 4 plus 1 is 12. 6 plus 4 plus 1 is 11. Carry my 1. 5 plus 3 plus 1 is 8. Oops, sorry, I mean 9. And 2 plus 1 is 3. Now, I have 39,121. Am I done? Nope, I'm still missing a 3rd part to my problem. Now I can check it off once I've added it. 39,121 added to your last one, 15,306. Notice again, I'm lining up my place values to not make a mistake. 6 plus 1 is 7. 2 plus 0 is 2. 3 plus 1 is 4. 9 plus 5 is 14. 3 plus 1 plus 1 is 5. Now, we have 54,427. Let's double check if we actually answered the problem. How many paper clips were in the closet? Well, that represents all of them added together. Yes, I added all my parts, so I know this is my final answer. I'm going to put this back in the tape diagram now that I know my answer. 54,427. Now I can write my answer as a final statement using my word problem to help me. So I can say, there were 54,427 paper clips, don't forget your units, in the closet. Boom, done. Alright, I can box that in. Alright, so that is my final answer. So that's how to use my addition algorithm with my tape diagram to figure out my total parts in order to find my whole. So that's my first problem. This is fairly easy. Now I have to move on to a little bit of a harder one. So let's try this one. This one's going to ask me to do several parts. So once again, I'm going to always start with cubes. Okay, we're going to circle the important numbers. Raffle tickets were sold for a school fundraiser to parents, teachers, and students. 563 tickets were sold to teachers. 888 more tickets were sold to students than to teachers. 904 tickets were sold to parents. Now I'm going to pause. I've done my circling of my numbers. Okay. Do we know our question yet? Not yet. Let's see if we can box in our question, or box in our action words. These are words, like I said, that help you determine if I'm going to add, subtract, multiply, or divide. Okay, they're any math words. So when I look here, I'm going to also look at my different groups or parts. The parts in this problem, we're not dealing with paper clips, we're dealing with people. We're dealing with parents, teachers, hey, that's me, and students, that's you. Alright, so now that we have our parts, we're going to also look at some of the math action words. I do see tickets as our units. I see sold to teachers. I also see 888 more tickets. Ooh, I always want to box in anything that says more or less. That really helps me out. And this was sold to students than to teachers. Anytime I see the word than, that must be a comparison. Now I have 904 tickets were sold to parents. Okay? Moving on to our question, part A. About how many tickets were sold to parents, teachers, and students? Round each number to the nearest 100 to find your estimate. First part I got to do, box in any action words. About, that tells me to estimate or round. Then it talks about parents, teachers, and students. I'm going to underline that whole question. So I want to know for 3 whole groups. That's important. I'm going to round to the nearest 100 to find my estimate. Here's where I get to start my tape diagram. I'm going to first put out my parts. Think about what are your parts for your little pieces of tape. Well, we talked about we're not using paper clips this time. We're using parents, teachers, students. I also see my parts right here in the question. So I'm going to stack them. So if you will notice in our tape diagrams, we're using this one. We're going to stack them on top since we're comparing. I know we're comparing because we have 3 parts, and I also am dealing with that word more. So I'm going to put parents, teachers, and students. Now I'm going to look back at my word problem and really close read to see what do I know for sure. That'll really help me figure out each part of my tape diagram. Let's start here. I looked and it said 563 tickets were sold to teachers, period. Okay, so do I know how many were sold to teachers? Yes, it told me right out, 563. So I'm going to go to teachers, and I'm going to draw a box. And I'm going to put that number right inside, 563. Now let's close read some more. 888 more tickets were sold to students than to teachers. Pause. We're talking about students, this amount. Do I know for sure how many tickets were sold to students? Not yet, because look, this is a comparison. 888 more tickets were sold to students than to teachers. So what that tells me is I have to use my answer from teachers, which we have already, and I have to add this much more. Well, if you want more, that means adding on. So I need to make my same piece of tape here with 563, plus a little bit more to represent 888. If this is really tricky for you, take it back to basics. Think about jelly beans with some small numbers. If Miss McCombs has 2 jelly beans and Mrs. Speth has 3 more than Miss McCombs, how much does Mrs. Speth have? You should say she has 5, right? Because if I have 2 and she has 3 more, she doesn't just have 3, she had 3 more. 3 plus 2 of mine. So that equals 5. That's why I had to add both parts. Now, here's the same way. If I had 888 more, that means that I had to add this part with my other part, my teachers, because those were my two comparisons, students and teachers. Now let's close read some more. 904 tickets were sold to parents, period. Do I know for sure how many tickets were sold to parents? Yes, it told me right here, 904, done. So I'm going to make my tape diagram. I'm going to make it a little bit bigger than my 563, and that represents 904. Now, my question says, how many tickets were sold to parents, teachers, and students? So what part am I missing in my tape diagram? I have my parts. It wants to know all my parts together. That must mean that I'm going to put a bracket over all of them, just like I did before, and I'm going to have A represent my answer. Now, we don't want to use our exact numbers yet because it says that I need to do about. I need to estimate. So I'm going to estimate these to the nearest 100 like it told me to, and I'm going to put it right above it. I'm going to use my approximate symbol. 904 rounded to the nearest 100 is 900. Okay, because 900 is closer to it. Now 563 to the nearest 100 would be approximately 600, because 563 is closer to 600 than 500. Okay, same thing here. I'm going to round. There's two of them added together because they're stuck together. So this one rounds to 600 plus 888 rounds to 900. Okay, so this one added together, 900 plus 600 is 1,500 or 1,500. Now, going back to my problem, I need to evaluate what I do. If I'm trying to figure out how many tickets were sold to parents, teachers, and students, that means I want to know all of it together. That means adding. So what I'm going to do is add my estimates, my rounding numbers. I'm going to add 900 plus 600 first. Those two numbers. Check them off. 900 plus 600, that's easy. It's the same one down here, 1,500. I can also do my algorithm. 0 plus 0 is 0. 0 plus 0 is 0. 9 plus 6, 15. Carry the 1, bring it down. 1,500. I check those off. Am I done? No, I still have one more. Students. We rounded this one off to 1,500. So I'm going to add 1,500 to my other 1,500. Well, that's really easy in my brain. I just think about 1.5 plus 1.5. That's 3,000. Okay? If you need to see the algorithm, 0 and 0 is 0. 0 and 0 is 0. 5 plus 5 is 10. Carry the 1. 1 plus 1 plus 1 is 3. Okay? So now I have 3,000. That tells me that approximately, use my approximate symbol, I have 3,000 what? Donkeys? Nah, tickets. So A is approximately 3,000 tickets. So I know I should probably get close to that number. Now, letter B. Exactly how many tickets were sold to parents, teachers, and students? Exactly. That must mean that I'm using the exact numbers in my tape diagram, no longer my rounded numbers. Again, I'm doing it for all three parts of my tape. Okay, so I'm going to add these numbers. I'm going to check it off as I do it so I don't make a mistake. 904 plus, I'm going to add to the next one, 563. Notice I'm lining up the place values, ones and ones, tens and tens, hundreds, hundreds, and I'm adding it in small parts so I don't make a mistake. 4 plus 3 is 7, 0 plus 6 is 6, and 9 plus 5 is 14. Carry the 1, bring it down. 1,467. Now, I'm not all the way done yet. I've only added 2 of my parts. So what I need to do now is add another 563. So I'm going to take 1,467 plus that 563, add them together. 7 plus 3 is 10. 6 plus 6 plus 1 is 13. 5 plus 4 plus 1 is 10. 1 plus 1 is 2. Now I'm at 2,030. So now what I need to do is I need to add a little bit more to get my final answer. I still have this one left right here, 888. So I'm going to take 2030 plus 888. 0 plus 8 is 8. 8 plus 3 is 11. 8 plus 0 plus 1 is 9. Bring down my 2. 2,918. I did answer my problem correctly because I added all my parts together, and it wanted to know all my parts added together. So A equals 2,918 tickets. Moving swiftly along to letter C. Assess the reasonableness of your answer in B. Use your estimate from part A to explain. So I'm going to use my answer from A, my estimate, and my exact number, B. Okay? So here's what I'm going to do. I'm going to see if it's reasonable. That means that my numbers are close. It means it makes sense. So when I look at this and I look at my exact number and my rounded number, if I were to make a number line, and I was rounding to the nearest 1,000 for this one, my low number would be 2,000, my high would be 3,000, and my mid would be 2,500. Now this exact number falls a little bit above this, and it's really actually close to my 3,000. So I'm going to put 2,918. We do know that it's closer to 3,000 than 2,000, so it rounds there. I notice the same thing here. 2,918 rounded to the nearest 1,000 is 3,000. So that means it makes sense, and this was why it's reasonable. So I'm going to mark my words on the side here. So this is the level that we are expecting for fourth graders to have. They've shown it mathematically and in words. Yes, my answer is reasonable because 2,918 rounded to the nearest 1,000 is 3,000. Therefore, my answer is close to my estimate and reasonable. So, that one's answered. Now, moving on to our last one, our subtraction algorithm. Okay, so once again, I'm going to always start off with cubes, and then I'll move to my tape diagram. I'm going to circle my important numbers. During the month of March, 68,025 pounds of king crab were caught. If 15,614 pounds were caught in the first week of March, how many pounds were caught in the rest of the month? I've circled. Now I need to underline my question. Back it up from the question mark. How many pounds were caught in the rest of the month? Now I need to box in math action words. Anything that tells me something important or tells me the units. My units in this case are pounds. Now it also tells me some specific times. It talks about this month of March, okay? So this is important, this whole month of March. Then it talks about some other specific times, as in the first week of March. What's the other important time? Yeah, right here. Rest of the month. I see one more phrase that might be important for us. How many? Okay? So now I need to determine how to draw my tape diagram, because this is going to help me solve and evaluate what steps to take next. So I'm going to look back at this and I'm going to see that when I see these numbers, I'm looking at during the month of March, so the whole month. And then I'm looking at 15,614 was caught in the first week of March. That means a part of March. Then it said how many pounds were caught in the rest of the month. So when I look back at this and I'm trying to find which tape diagram to use, I'm noticing that they gave me a total for the month of March. So they gave me a whole. And then what they gave me is they gave me a part of that March. They gave me the first week of March, that 15,614. So they gave me that part. Now I have to figure out how much for the rest of the month. The rest of the month would represent this to get to my whole. So here's how I'm going to draw it. I'm going to draw my whole. And the whole thing for the whole month of March, they said, was 68,025. Okay? Now, the other part that I'm going to do is my part. They said if they've given me the total, and they said the first week of March, so a small part of this. I'm going to make a small part of my tape. 15,614. Now it's asking how many pounds were caught in the rest of the month. That means how many more to get to my total. So that represents my A, my answer. Okay? If I have a missing part, I probably need to subtract from my whole in order to figure out how much more to get there. Usually you might say 15,614 plus what would get you to your total. Another way to think about that is take your total, subtract your small part to get your last part. Okay? So here's what I'm going to do. I'm going to set this up as a subtraction problem. Take my bigger number on top, always. Subtract my smaller, lining up my place values. Okay? Lined up my place values. Now I get to subtract. 5, take away 4. Am I ready to subtract? This is a strategy we use in 4th grade. RTS, ready to subtract. When I think about this, I want to look at each place value before I ever write down an answer. So are my ones ready to subtract? 5, take away 4. If I had 5 jelly beans and they wanted to take away 4, could they do it? Yeah, so I'm ready to subtract in the ones. How about my tens? 2 tens, take away 1 10. Am I ready to subtract? Yes. Hundreds. 0 hundreds, take away 6 hundreds. Again, you're always reading top to bottom. If I have 0, can I take away 6? No, I cannot. So that means I need to borrow, which means I need to unbundle. So if I'm unbundling from the next place value, I'm going to go over to my thousands. I unbundle 1. When I take away 1, that becomes 7 thousandths. If you unbundle 1, you can give 10 more right next door. So 0 plus 10 equals 10. So just remember that. If you don't have enough, knock next door, borrow some sugar. Borrow 1, give 10 more next door. You're unbundling to give 10 more next door. Now, hundreds. 10 hundreds, take away 6 hundreds. Am I ready to subtract? Yes, that's good. Now my thousands. 7 thousands, take away 5 thousands. Ready to subtract? Yes. 10 thousands. 6 10 thousands, take away 1 10,000. Yes, ready to subtract. Now I can start my answers. Start from top to bottom as always. 5, take away 4. 1. 2, take away 1. 1. 10, take away 6. 4. 7, take away 5. 2. 6, take away 1. 5. So now my final answer here is 52,411. Did I really answer what it asked for? How many pounds were caught in the rest of the month? Yes, I subtracted from my whole one of my parts and got the rest of the month. So I can put this right inside and write my final answer as a statement. £52,411 of crab were caught in the rest of the month. It's very important you include your units and you write your final answer as a statement. And that's how you do your addition and subtraction algorithms with your tape diagrams. Please let me know if you have any questions at all.